All right. So, welcome to another devlog. Uh, it's pretty funny because I tried to do this 2 times and I found errors both times with memory. So, it's a great way to test your software is to self-demo it to yourself to see what's wrong because you will find something. Yeah, that's pretty great. So, I just spent the last 2 hours fixing things, which is fun. But anyways, so I wrote a little language. I have read this book. Oop, there you go. Writing an Interpreter in Go by Thorsten Ball. I thought this book was really great. I highly recommend it if you want to learn about how to write your own programming language. It's pretty high level, but I think it touches on all the areas that you need to basically get into it. I'm no expert, so I really appreciated it. It kind of goes over the basics like writing a lexer and then parsing the tokens and building an abstract syntax tree and then evaluation of that tree to print results. It doesn't get too far into detail into supporting types or anything like that, but it does give you kind of like a good start of like where next to go. So I thought that was great. And so I kind of took on the challenge because I've always wanted to write my own programming language to write it in C because I really like C. The book is in Go, so there's a lot of things that I had to figure out, and that was a lot of fun. And yeah, so let's jump into it, and I can kind of explain the language I designed. It's very, very basic. I don't support maps yet or arrays. I just support basic primitives like integers, floats, a boolean, byte, and string, and some other things. And I really just wanted to create a proof of concept or a very basic proof of concept before I start getting into the advanced data structures and things like that. Yeah, so a little demo. If I can get past here, I can just do that. Okay, so that builds it. I can clear this and just do A out. So you must provide a file path. So pretty good. My interpreter requires a file, so I've set up a file here. Samples demo. Okay, so I got an error. Just you need to have a main function in my programming language right now. So let's go and define that. So go func main, and we're gonna just do that. And will that solve the problem? Nope. So here's a bad parsing error, but you can't have an empty function. My language right now, you have to have something in it. I'll probably get rid of that, but why don't we just put an expression in there? One is an expression. Let's do that. And so the program now returns a noop or no operation. So that's great. Now I want to actually return something. So I haven't actually tested this and see if it breaks, but return 1. Let's see if it does anything. All right, so here's our first issue or a thing that I've made because I really like JavaScript and I also really hate it because of this reason, which is doesn't have types. And this is why I like Go a lot. So I kind of wanted to like have a blend between the two. So you have function main return count doesn't match. So it's an okay error message. But I've defined here a return statement, and my main function declares nothing to be returned. I have plans to support multiple returns. I think that's always awesome. But why don't we just put a single return here and not break the program for now and do that. Okay, so we've successfully created a program. It has one function, and that function returns an integer. and it returns 1. So program results is 1. Awesome stuff. Yeah. So now we can continue. Here's an example of just doing some addition. Great stuff. Now it returns 2. That's awesome. But why don't we do something else? Why don't we write another function, and this function is really going to do nothing. It's going to take an A, and it's going to take a B, and it's going to be an int, and that's going to be an int, and it's going to return an int. And so we're going to do return A plus B, and that's it. And here we are just going to return 1 and 2, and that should equal 3. So we've defined a function. It takes in typed arguments, and it returns a type of int.
So there's one thing I wanted to add here, which is that the types are checked in the arguments as well. So you can't change this to say, add a true, because B is expected to be an int. So when you try to run it, it also gives you an error message.
So there you go. It returns 3. So this is really fun for me. I think I just love building programming language now, or languages now, or just continue building the one that I think is fun. But this is kind of like the whole thing. It's like I just want like JavaScript or something, but without JavaScript, and I want something simple, just a very easy to write language. There's no closures, and everything is just defined as is, kind of thing. So that's very simple, and that's kind of like the base concept. It's nothing new. So I'll save like the more advanced developments for later videos. But the whole kind of thing is like this kind of like type system, which will get a lot more complicated in the future version if I decide to continue this. But for now, let's carry on with some other features that I've built. So the one other feature I've done is I have a constant, so I can say A is equal to 50, and that declares a variable, and I can pass that into my function now. So this should return 52. Yeah. But why don't we say like, I don't like 50. I want it to be I want to do 50, A plus A plus 2. This is just obviously demonstration purposes, but this should, okay, that shouldn't work at all. And, oh no, that should work. That's totally fine. What I meant to do was do this. I want to say A is equal to A, and then return A. And this should throw an issue. Right, so here we have can't assign new value to constant. Just basic stuff, right? Not let. Var, so now it's an actual variable. And int is 52. A works, right? One other thing I believe I did in here, I'm not sure if I actually checked this or made the proper error, but we can try it. A is equal to 7. Let's see if that does anything. Okay. So what I'd like is that parameters can't be mutated. I think that's just something that should be supported. It's like you can always rely on the parameters, the arguments not changing once they go in. But yeah. So there's that. The other thing that is nice is that it's all type inferred. So you can't do this, or you shouldn't be able to do this. A is equal to hello, right? I think I might break this, but yeah. So you cannot change variable type after first assignment. So it's locked. Um, and that even works if you just use it's inferred by everything. So let's do 1, 2, and then we can do that, and save that. So that should work. Even if you put like true. Yeah, you can't change it. So works great. This means there's no funny business like in JavaScript. It's like very loose. In JavaScript, you can have like all these like weird things, and you can have strings that then turn into numbers and stuff like that. It's like none of that would work here. So I like that. Now let's try something different. Let's see if this works. I'm getting a little bit out of my tested territory here, so things may break now. So we can do if a is greater than 50, then I'm going to say, hey, return hello. Otherwise, else return boop. And here I can return oops, which should never happen because the else, right? So if I do that, let's see if I broke it. Identifier boop is undefined. Oh, right, I did something dumb, which I'll probably change. Strings in my language, for some reason, I made a very experimental decision to use the backtick for strings, and I did this on the point of that the backticks aren't used in regular English. So I wanted strings to be kind of special. So if you were to type like oops, quote, in or quote, you're not worried about a lot of that a lot of the time. So, and strings are only supported by the backtick. You can't do like triple quotes because that's really annoying, or single quotes because then you have issues with using quotes in English. And yeah, you can escape the backtick, or should be able to escape the backtick, and the backtick is not used as much as other regular everyday string characters. So that was kind of my thought on that one. Let's see if it runs. It works, so that's great. The other thing that we can do that I spent a while trying to debug a buffer overflow issue was you can have loops. I only support. I'm actually thinking going for the keyword loop instead of for, because for would be a misconception of how it's supposed to work. But there's no semicolons in the loop at the moment. I'm not too sure if I want to support them, but I also think I'm lazy if I don't. But I also think it's kind of weird to read, putting the initializer and then having the condition and then the incrementer. I think just having a basic loop where you don't have any of that jargon might be cleaner. Although I think the shorthand definitely can be helpful, but So let's do that and see what happens. And here we'll put over 50, and we'll put under 50, and we'll do that. Under 50.
Okay, so that was wrong. It wasn't under, well, it was under 50 because there's a bug, but I just fixed that. So as you can see, it's over 50. There's a bug that's causing the loop to end on the first iteration, but I fixed that.
So that's an example. Obviously, if you could print the number, that would be nice. I mean, I could have done that by returning the number, but having some I/O, I think, I need to support that, but that's all API stuff. So I'm just focusing on the language. But yeah, that's kind of the language in a nutshell. I think that's like pre-alpha, not even alpha, because the next thing I want to work on would be structures, maps, and arrays. And I have this idea of how I want to deal with structures, particularly. So structures internally under the hood will just be a hash map of names to qualifier names, that can work in the code, to whatever. It doesn't really matter. But I also want to have, you don't declare structures like you regularly would, like with JavaScript prototype or a C structure or a Go structure or anything like that. You kind of just create them in your code like you do with JavaScript objects, except you can apply a signature to them. And that signature is basically just like a property interface. And so that's how you pass things around, because one of the biggest problems I have is having to rewrite functions. I don't want to rewrite functions. I just want to pass whatever I want to pass in. As long as it has the fields required, then it can be used. So I call it a signature. It's probably a bad word, and it's very much more closer to the idea of interfaces. So basically just like an interface-based language that's type checked. Currently it's all typed at runtime, but I would like to have type checking done when the script is loaded. So it can go through all your code and then see like, hey, you tried to use this expression which would resolve to an int or something like that, and it goes here. And then I'd also like to have something where you can, because under the hood it's just memory, I really want to be able to easily cast to other types. So even if you have like a car, a byte, a bool, sorry, not car, like a byte, a bool, a string, whatever, I'd like to have some very easy type changing. Maybe it only applies to numerical types, but definitely upcasting from a byte to an int and then int to a float, like that should be very easy. It can only go in one direction, I think, though, to make things simple. Otherwise, what you can do is you can have explicit casting, which might just be a function that you call that's global, like any function's global, and it just like returns like the casted version. So if you have a float, you can call like int expression and put the float in it, and it will turn it to an int. Or you can put like a byte, or call byte on a float, and it turns it into a byte, and it's like capped at the max or something like that. Or you can convert anything from like a float or anything to a bool from float, int, car, string. If it's like an empty string, then it's false. If it has any characters, then it's not false, like that kind of thing. Yeah. And then one thing here is like the strings work. They should work like any other strings, and maybe we'll catch it here, crash it right now. Why don't we say like, hey, var str is equal to hello, and we'll put that there, and we'll say str is equal to str plus world. Oops. Oh my god. Do that. And then here, we do string is equal to string plus Tom. Get rid of that, and then we'll put string here. Yeah, so strings are just arrays under the hood. I have no idea if this is going to work. It works. Okay. That's fun. I didn't need to put the extra space there, but hey. Yeah, so strings are just arrays, which is cool, and I would really like have the same syntax for slices that Go has. I think that's really cool. And if you don't know what I'm talking about with that, it's when you can use a portion. So you say like, I want this like the first or the last, it's from 0 to 5 characters or something like that, and it returns a string, just those characters. Yeah, that kind of notation is really cool. I think having that array slice notation is cool. Yeah. So that's kind of my first programming language. And I don't really know if I'm going to get into the code. The code's all on SourceHut, so you can check it out there. It's very basic. I do exactly what it says in the book, which is, you have your Lexer, and you go through your tokens, and then you have, you build your AST tree. So that's the builder part, and then you have your evaluation. So you have your Lexer, parser, and then evaluation. And then I have a bunch of stuff, and it's all done in C. So it's a bit boring to go over, and I don't do anything cool in it. It's very, very dumb code. But yeah, so that's been an awesome few weeks. I've been putting this kind of hacking on this every now and then, and I heard it took the guy to write JavaScript in 10 days, and I find that very intimidating because I don't know how you can write a language in 10 days, but I guess I'm also learning. But very impressive, none the least. Anyways, that's it for devlog. I've had a lot of fun, and I'll see you guys next time. Peace out.